welcome back. Just to keep you updated on progress with the Is It Time for Tea machine, I've printed another head, a new version, which is greatly improved. It's now got mechanisms inside. I spent a long time trying to sort out how I could get the jaw to open and the eyes to move, and in the end I thought, keep it simple, string or fine chain like I've used on the other machines, like the barometric prognosticator, where a chain moves the bellows to make the cuckoo sound. So something simple. I started off by using the little red pulleys that I've used before on some of the machines, but if you're going to use things like that that look that nice, it's a shame to waste them when you can't actually see them. And as with all these steampunk machines, all the mechanisms ideally need to be on show. So Brian of Britain here suddenly realised that you've got a 3D printer, print a pulley, which I did, and they came out really quite well. Good enough for this job anyway. And some spacers, and this new head's got the 2 shafts through it, 4mm shafts. So I've got a little lever on the back of the eyes, so as the eyes move, they can be moved by the chain or string or whatever, and the same with the jaw. On the inside of the jaw there's a little hole here, so I can connect a string to that. Haven't quite sorted out how to get this movement yet, how to fix where to fix the chain for that. Working on that. What I've also done is built really good quality, very proud of this, really good quality frame cabinet. It isn't really, it's just something so I can develop this. Unlike all the other machines that I've done, the Is It Time for Tea machine, I haven't planned carefully. I've done the original really nasty sketch just to get an idea in my head straight. And what's exciting about this, like the epizoescope that I designed, was I'm not planning it all to the nth degree first on the computer. I'm just doing it methodically, one thing after another, and just seeing what happens. So as part of that, I've got the neck mounted on the Lazy Susan bearing that I mentioned last time, and that turns really nicely. That works okay. And there's the hole up the middle for the control strings to go. Don't know whether that's even focusing. Let's see. For the control strings to travel through. I've got another Lazy Susan bearing, one of 2 that I bought ages ago for something else and always wanted to use for something, that I'm going to put at the bottom, and I'm going to link the 2 and have some sort of mechanism between the 2 that's actually going to make the head move and have all sorts of other bits moving as well. So I did some research and came up with research on these amazing automatons from Victorian times. Absolutely incredible. This is the inside of the one that a boy that actually writes with a quill pen on a piece of paper, and it is stunning. I mean, just the ingenuity is incredible, and I love the look of this, the silver or the steel against the brass. I mean, it just looks stunning, and it's just beautiful, even though it was all hidden away inside. They took so much trouble to make, well, he did, Jacques de something or other. I must look it up and find out. Awful with names. And all I need to do is to hide these servo motors that I'm going to use to control everything. And as I said before in the last video, these are great servo motors because they're very powerful. They're designed to control steering and things on radio controlled vehicles or robots or whatever, and they only need one wire, one signal from a computer to tell them exactly where to position themselves. So that's great because it means I can have lots of these connected to one Arduino. So watch this space. I'm going to start working on this today, and it is lovely not having designed any of it yet, just seeing what happens, seeing ideas that I have, seeing how it goes. And remember, all these bits and pieces, well, all my other inventions and other components and things are all available on my online shop at steamhead.co.uk. I'm going to start cutting out the copy that I've made of that wonderful rotary cam or some sort of system from the automaton, because I just thought it was so beautiful, the mixture of brass and steel and things. So let's press start. I'm going to cut out, designed it with 4 layers, and let's just focus that's it. The first is the separate the front part with lots of little cams that look like that you can adjust how far they go out, and each one's numbered. That's the first layer. The second layer are the steel cams that actually do stick out. Then there's another layer to give a little bit of separation between the cams, which I'd like to use, and the gear at the back, because I need a little bit of a gap. So if I'm going to drive the gear at the back with another gear, I don't want it to rub against cams and things and knock into them. So here it is. This is 2mm acrylic. It's engraving the numbers, because that's, well, they had letters on the original automaton, but I thought it'd be really nice, because if I was getting this to work properly, I would need to know the position of each cam. And this is on a lower setting. This setting is actually 100 something or others per something or other, 15% power. A funny looking array of, or circle of little bits and pieces, little engravings there. That's to simulate the screws, the little steel screws that are in the original assembly from the photograph. I didn't want to have to put in 29 or 30 screws, so I thought I'd just engrave them in the back piece of acrylic, which I'm going to paint silver or steel colour, and then the front piece will have lots of little holes just exposing, or so you can see each of the engravings, so it'll look like there's a row of screws. That's what it's cutting out at the moment. So the power's now gone up, it's done the engraving, and I'll have to say it's been lovely working in 2 dimensions again, even though I keep trying to flip the drawings over to see the 3D version. I've said before, an old dog learning new tricks. It takes some getting used to. So this is going to be brass coloured, because the Victorians, any sort of precise machining, they did favour brass because it machines so nicely. But then the cams that it's now going to start cutting out, they would have been made of steel, because it was harder, so much harder than brass, that it would have lasted. So this is the cam shape, and I want to have ball bearings rolling on this, so as it turns round it does actually move all sorts of levers and other bits and pieces, so it gives the impression of actually working. So the bits are cut out now. I need to sort out what colours to paint them. On the original it had the brass background, then the steel cams, then the brass foreground and steel screws. But having thought about this, I'm not sure I'm going to be able to do that. I'm going to have the brass gear at the back, then I'm going to have this which covers all the little screw heads, the engravings that make it look like screws. So I think I'm going to make that steel colour. Then I'm going to have the spacer, then the cams, which will be steel, and then the front part with the numbers engraved that are going to be, that's going to be brass as well. So I think I might do these 3 little things as well, because the original had 3 lovely little bits at the front. So I think I'm going to do these ones steel as well. I'm going to change it around and cheat a little bit, but that's okay. Needs must when the devil rides. And that's what my mother always used to say, always manoeuvre before you hoover. Always hoover before you manoeuvre. It's been a long time, but hoovering the pieces ensures, hopefully, that there's no dust left on them. You always get, otherwise, a bit of dust just in the wrong place. These will be interesting without getting them sucked to oblivion, you know. So these bits are going to be the steel colour, Oh, that's right, it's landed the right way up. What I found is, the best way to do it is just to put a light coat on 4 sides, turn it through 360 degrees, clear the nozzle, and then let it rest for a while. And then it dries fairly evenly. If you put it on too thickly, it will never dry. And there's always the problem with this silver paint that it just for days afterwards, it seems, if you touch it inadvertently, you get a fingerprint on it. Whereas the brass paint, these bits, these are the thing I was talking about just now. But the brass paint is brilliant. It dries within 10-15 minutes and it's impervious to everything. So I've got the top assembled again, painted brass paint, and that's sitting on the Lazy Susan, the top Lazy Susan bearing, so it turns perfectly. So I'm going to put this piece back on once I've fixed the neck on. I need to sort out where the neck's going to go and then fix it into place. I've left the glue to dry for about, or set for about 5 minutes. That's the problem. If you try and glue onto paint, it's not that strong. I think what I'm going to do is to glue it into position just to hold it slightly in the right place, and then drill down 3mm holes to put the rivets in. They will then obviously enter fresh plastic that's not being covered in paint, and the rivets should glue in properly. So I'm getting ready to drill these holes, and as you can see the 3mm drill bit in the normal pillar drill chuck is not long enough, but luckily somewhere here I've got a much longer drill bit. I don't think they're very good quality because they go blunt quite quickly, but hopefully I can get it to line up. Bit of a recipe for disaster because everything's wobbling about, but we'll give it a go. So the longer drill bit is in, so I can now reach the holes. It's just if I can actually get it away. So it's all a little bit iffy at this height. So all the little copper rivets are glued in. I think they look really good. It's nice to have a mixture of brass and copper against the wood, and also the idea that this is porcelain, some sort of ceramic, which is nice. Now it's time to put the chain into the head. So to get all these bits working, need to get the chain connected. I didn't want to use string because Victorians wouldn't have used string, they would have used chain or something like that. Now, this is an amazing chain. I got it on eBay and it's actually welded or somehow fitted together so that the links aren't loose. Absolutely incredible, it's so strong. And I found that I had some spring steel wire that would just push through the little bit of pressure. I've put a dab of glue, super glue on it to hold it. I'm going to cut that end short as well so it can then fit through a hole in the head, hold it in place. I'm working on something like this polythene. There's a little top tip here. If you work on polythene, super glue doesn't stick to it, it always releases. So brown packing tape or this sort of little bags, it means that you can put a blob of glue on and it won't stick to anything else. You can release it and then work with it. So there we are, top tip. There's the other one I'm going to use for the eyes. So eyes and mouth, and one for the neck as well. This is so exciting because I've now got the head mounted. So I can move the head up and down by pulling on the chains. The mouth can open and close, and the eyes can close or roll down and open again. And also what's nice is you can angle it quite a lot and the eyes and the mouth don't change that much, which is great. So next job is to work out how to mount the servos and the things that are going to control it. And it can also turn around. Really exciting. Thanks very much for watching, and remember, all these bits and pieces, well, all my other inventions and other components and things are all available on my online shop at steamhead.co.uk. Thanks very much. Bye.